All right, this video is for lesson 11.3. Our topic today is distributions of data. We're going to be focusing also on how, like visual representations of data. So first of all, we need to talk about all the different types of data that you possibly might be collecting. So not all data is the same sort of data. There are different types. The first way that we could divide our data into different types is that some data is qualitative. These are things like gender, color, satisfaction level. Perhaps on a survey you have a question that has a yes or no answer. That would be a quality. Qualitative data is not numeric data. It's things that are not numbers. So if your data is about anything that doesn't have a number associated with it, that would be qualitative data. Data that is numerical is called quantitative data. Quantity refers, or quantitative is, the same root as quantity. Quantities are numbers. How much? So quantitative data comes in two types. It could be discrete data. Discrete data is countable. It has a finite number of possible values. The number of kids in your family. You could count how many children. Uh, the number of pitches that a pitcher threw. Those are all discrete. You can count how many. Continuous data is not countable. You can't count it. Usually it comes from some sort of measurement. You could measure how tall a person is. You might measure the speed of a car. But it's things that you can't measure. They're still numbers though, and sometimes the way to check if it's continuous instead of discrete is think about if it could be between two values. So you might be 6 feet tall, you might be 6'1". Could you be something in between that? Well, sure, you could be 6'1.5" or 6 foot and 1/2 inch, I guess. You might go 60 miles an hour, you might go 61 miles an hour, you could go 60.5 miles an hour. You're going to hit every value in between, possibly. So that's sort of one way you can sort of tell if it's continuous or discrete. So I want you to go through this list and decide which type of data each one is representing. I'll give you a minute to do that, and then I'll tell you the answers. You can pause if you want, I guess. So the first one, the color of shirts. Color is not numeric. This would be uh, qualitative. The number of seatbelts in a car, you would count that. It is discrete. The number of eggs used for making a cake, the recipe would tell you how many eggs. That's discrete. The speed of a plane, 2 minutes after takeoff, you would measure that speed. It's continuous. The number of bikes sold by a garage is discrete. The time that it takes you to solve a Rubik's Cube, time is always considered to be a continuous variable. The height of trees, you would have to measure that. That's continuous. The gender of the members in the band is a qualitative. They are either male or female. The number of bedrooms in a house is discrete. You have to count the number of bedrooms. All right, so we're going to be focusing on ways to display data and how data are distributed. So the first way that you might display your data if it is qualitative is with a bar graph or a pie chart. Now I'm not going to be having you make these two displays this year. I just wanted you to be aware that if your data is qualitative, these are the ways that you might display that. And you will notice that you have the categories here. And then sometimes you will count how many members there are in each category. This is showing the different categories. And for a pie chart, you've turned those into which percent or what percent each category represents. So qualitative data would be displayed in these ways. If you have quantitative data, there's a lot of options for how you could display your data. We're going to talk today about histograms like this. box plots like this and frequency tables like this. So the first thing I want to talk about is box and whisker plot. You should have in the past already studied box and whisker plots, so this is kind of a review of that. You probably spent multiple days on this in a prior class. Box and whisker plot uses the quartiles to bound that center box. So you can see on the display Q1 and Q3. The median is shown as a bar in the middle of the box, not necessarily centered, but somewhere inside that box, depending on where its value falls. And then you have these whiskers drawn to the minimum and the max. Sometimes you'll see a little bar there, sometimes you won't. These 5 statistics, the minimum, Q1, the median, Q3, and the max, are sometimes referred to or often referred to as the 5-number summary of the data. So if you see something talking about a 5-number summary, these are the 5 numbers that it's talking about. So let's make a box and whisker plot for this data set. We have the temperatures of the water, the Gulf of Mexico down by St. Petersburg, Florida. For each month of the year, they took the temperature. So we can get from our calculator a 5-number summary. We worked on that last time. You're going to go into your list and you're going to put in that information. And then from the calculator, you can get the 5-number summary. And hopefully I won't have a typo in my data. So remember to put that in. If you have forgotten, you'll do stat, and then you'll do edit. That will take you into the lists. Type your information into list 1, then you'll do stat, go over to the calculating menu, and you're going to select one variable stats. And from there you should get a nice display of the statistics for the data. So our 5-number summary, our minimum of this data set is 62. Q1 is 66. The median is 76. Q3 is 84. And our maximum is 86. So if we're drawing a box and whisker plot, what I like to do is put my lines for these 3 values, connect them, and then go over to my whiskers. So for this data set, it would be like right here, 66 and 84, and the median is at 76. So that gives me the box. And then I have a whisker over to 62 and a whisker over to 86. So this gives me a really nice representation of the data, and I've matched it to that number line. So if you have a number line, you should make sure you match it to that number line. Here's our box plot showing the distribution of the data. All right, well, our calculator has a really nice box plot display as well, and one thing that makes it handy to use your calculator is you can actually graph multiple box plots together to make comparisons. So the instructions are on your notes page at the top of the page. You can look at that. And we're going to do this. We're going to use the box plot to make a display of the data for the heights of the players on the Jazz roster this year. Those heights are given in inches. So let's see. I'll show you on my calculator on the screen. All right, so if I'm on my start screen, it would look like this. Hit stat and edit to bring up the list. I have some prior data in here, so I'm going to clear out that list. And now I can put in the heights of the Jazz players. And those are on your page there. And we'll get these all entered. Okay, we've got the 15 players in now. So to make that box and whisker plot, instead of going back into stat and calculate, we're going to use right over here this stat plot. So you do second and that y equals button. And right now you can see all of my plots are off. If you have some of those that are on, you like number 2 or number 3, you might want to turn those off. Otherwise you'll get errors. So I'm going to hit enter to go into plot 1 and turn it on. So just hit enter while you're over the on selection. And you can pick the type. Now yours may have been already on this scatter plot. You can go over, and you do have to use the over button to get to these other types of plots down here. So we want to put it on a box and whisker plot, and then we can choose which list for it to be on. Right now it's on list 1, and my data, I put it into list 1, so that's good. If your data was in a different list, you could totally use the second button with these number keys down here to get a different list, but list 1 is right for me. So when I hit graph, it may come up directly depending on how it was zoomed, it may not. If you don't see your display, or if you want to change the zoom, the ninth zoom, so zoom, the ninth choice in your zoom menu is, oops, I went too far, is zoom stat. Oh my goodness, I am all over the place here. Okay, so the ninth choice there you can see is zoom stat. That zoom is really great to take it to a really nice display of your data. So here is the box and whisker plot for the Jazz team. Now when you have that box and whisker plot, if you hit the trace button, it will actually show you right on your screen the median. You can see the median is listed right down here in the corner. And if you go over, it will show you Q1, minimum, and if you go in the other direction, Q3 and the max. So that's a really quick way to get the 5-number summary as well. So let's plot this onto our sorry. So the max was 85. Here's the max. We've got the Q3 was 82 and the median was 80. 82 and 80. And I just need those lower ones. 78 and 73. Okay, so here's my box plot for the Jazz. Now, the nice thing about the calculator is that we can actually, in our other list, we can put in another team and then make a comparison of the two. So back in stat and edit, I'm going to go over to my second list and put in those 15 heights for the Spurs players. And you just type in each one and hit enter in between. And we should have all 15 players now. So if I go back into, second stat plot, I can go to a second plot here and turn it on, and mine happens to already be set to a box and whisker plot, but you could go over and set it to that. And then it may default to list 1, it may default to list 2. You need to make sure it has the list that you put in the other team, so list 2. So now when we hit graph, it should have both of those teams shown. And you could sketch that second box plot with the Jazz plot. I would in some way label them so that you know which is which. And then if you needed to make some comparisons, which team has a higher median, which team has a longer range, and so forth. You could use the box plots to answer those questions really quickly. Remember too, when you're looking at box plots, if one of them was cut off the screen or something, you can always use zoom 9 to rezoom that, maybe to fit the data a little better. Okay, so now you know how to do two box plots together. In your notes, there's space to do one on your own with some average number of minutes spent studying or spent participating in extracurricular activities. For the video, I'm going to skip that, but it is a good practice. Okay, so a second way that you might display quantitative data, really you could use this with qualitative data as well, is that you could display it on a frequency table. Sometimes people get confused when they see this and they use all of the numbers for their data, but in this case some of the numbers are just frequencies. In fact, it says the word there in this table, but in this second table it doesn't. What this is doing is it's kind of shorthand. Instead of listing out that number 13 7 times, they're saying for the age group 13, there were 7 members. 1, 2, 3, 4, 5, 6, 7. And instead of listing out the number 14 12 times, they're putting it in a frequency table. So you can see that if they had listed these out individually, it would have taken up a lot of space and maybe would be difficult to analyze, but a frequency table sort of is just condensing that and making it a little more manageable. There's ways to get your calculator to use frequencies as well, but mostly I just want you to recognize. So this is saying that in 1 yard there were 3 trees, so there's, whoops, sorry. So there's only one value that had 1 yard had 3 trees, 5 yards had 4 trees, 7 yards had 5 trees, 4 yards had 6 trees. So you can see that the frequency table is just sort of a way of condensing this list of data into a little bit more compact representation. So just be aware of those. All right, the last way we're going to talk about for displaying data is a histogram. A histogram is a graphical display that uses bars of different heights. Usually the heights are either the number of members of that group or could also be percentages. So it's really similar to a bar chart, which you would use with categorical or qualitative data, but it is numeric. So basically it's like each of these bars, this bar represents all of the data that fell between 60 and 70. This bar is representing all of the data that was between 90 and 100. So if you have qualitative data, you'll use a bar graph. It'll have gaps, and each of the bars will be a category. With a histogram, each of the bars represents a range of numbers, and there are no gaps in between those bars. So let's look at some histograms, sorry. So we have here the distances in feet of the punts that were achieved in a punting competition. We're going to use our graphing calculator to generate a histogram. So let's see, here we go. I need to go back into my list, so stat edit to clear out that list. To get into the list, I'm going to clear out list 2 and list 1 both, and I'm going to put my data into list 1. So there's quite a few of these, distances that we'll have to type in. And try to keep an eye on your list as you're doing it to make sure you don't have any typos that could make your plot incorrect. Here, get this in. Sorry. make sure as you're doing your homework and things that you are actually going through this process. You will be required to do these, to demonstrate these skills on your test. And if you have never practiced it on your own, you will not know how to do it. Okay, so we have the data in, and I'm going to go into the stat plot menu, and I need to turn off the second plot because we don't need it this time. And so now I go into plot 1, and it is on, so that's good. On the type, I'm going to go to this histogram choice now instead of the box plot choice, and just make sure that it's using the list that you put your data in. My data is in list 1, so that's good. If you need to change that list number, you can. And hit graph, and you may or may not get a very good picture. This histogram is not a good representation of my data. You need to remember to adjust the zoom to fit your new set of data. So here is what it really looks like when it's zoomed more appropriately. So you could sketch that data or that histogram onto your notes. So you can copy that, will be faster. Okay, so here's what the data looked like from my calculator. And so you can just sketch that into your notes, and I'm going to show you a couple more things in the calculator. Number one, you can adjust the width of each of the bars if you want. It will automatically sort of calculate what it thinks they should be, but you can adjust that. Let's hit the trace button really quick and see what this shows us. When you hit the trace button, it lists a little min and a max, and it has an N over here to the side. So the min and the max are telling you what the lower bound and the upper bound of that particular bar is. So this is saying that between 29 and 39, there were 3 data values in that within that range. And then if you go over to the next bar, it's telling you that there were 4 data values between 39 and 49, and so forth. So it tells you how many data values were in each of those sets. So this highest bar had 8 data values in that range between 59.5 and 69.6. So you can adjust that window if you want, and instead of having it start at 29, you could start at 20 and have it count by tens. So the scale is what it counts by. And sometimes that gives you a little bit better picture. But the one that it zooms to automatically is probably good enough for what we're doing this year. Let's see, what else does it ask down there? It says, what are the mean? Oh, where are the mean and the median located? So let's do stat and calculate the statistics for this data set. And it says our mean is 59.9 and our median is 60.5. Oops, sorry. Let me go back to the picture here. So if we hit trace again, we can sort of see where those different values are. 59.9 and 60.5. So the upper bound of this is 59.9. So the median and the mean are both located really close to the edge of this particular bar. So the mean and the median are both really close to here. The mean was 59.9 and the median was 60.5. How might we describe this? We'll actually get into that in a second. Here we go, symmetric and skewed data. So when you look at a distribution of data, you can decide if it's symmetric or if you think it is skewed. So the symmetric ones, like this one in the middle, The mean and the median should be approximately equal, really close to each other, and then the data are evenly distributed on both sides, and it gives you this nice symmetric, like mirror image sort of picture. Uh, the data might not be symmetric though. Sometimes the data is skewed to the right, which would be, yeah, anyway, positive or negative skew. I think about the location of the tail when I'm deciding what the skew is. So if the tail of the data is on this negative side, then it would be a negative skew. If the tail is on the positive side, it's called a positive skew. Um, the mean and the median for skewed data are not close to each other. They can be uh, that tail sort of pulls the mean to that side of the median. When your data is symmetric, the best report of its center and spread is the mean and the standard deviation. So whenever I look at a set that has a symmetric distribution, what I pay attention to is the mean and the standard deviation. If your data set is skewed or it has a lot of outliers, a 5-number summary is a better representation of the data. So an example of this is this particular histogram. It's showing the scores on the Unit 10 test for all of my students. So this includes data of about 130 Math 3 students. The mean of the data is shown in green. It was between 80 and 85%. The median of the data, though, was 94%. And then you can see there's a group of students over here that actually didn't even take the test yet. They were absent or something and haven't come in to take their test. So when I look at the distribution of test scores, it's almost always skewed, and in this case, it's a negative skew. So when I'm deciding, when I'm thinking about where the center and how spread out that data is, I almost always pay attention to the median and the 5-number summary. The mean is always being pulled lower because of the skew of the data. Okay, so let's use our calculator to create a box plot of this data and describe the shape, and then we'll use either a 5-number summary or a mean and standard deviation to describe the center and spread of the data. So I'm going to go back to the calculator screen and stat, edit, whoops, and clear out my data list. Okay, so let's see, let's put in this data, but it's the survival time in days of some guinea pigs that were injected with a bacterial infection for a medical study. Maybe they were testing an antibiotic or something, so they wanted to see if that helped the guinea pigs. I don't know. It's a little dark, I know, but it's okay. So we put in the data. And this time we're going to look at a box and whisker plot. So if we go second, stat plot, right now it's set on histogram, so I just need to adjust that to that box and whisker. It already has list 1 as the set of data it's using. Hit graph. My picture's not very good right now. I need to rezoom it, zoom number 9, and here is what it looks like. Now, sometimes this one is kind of, I think, really difficult to decide if it is symmetric or skewed. I definitely think it has a longer whisker on that right side, so it might possibly be a positive skew, but the median is, I don't know. It's hard. It can be hard to tell. So usually I look for the longer whisker when I'm deciding if a box plot is skewed. Here's a picture of that. You had a picture of it in your notes. So I usually look for the location of the longer whisker. You can see here the positive skew had a longer whisker, and here the negative skew had the longer whisker on the negative side. But sometimes it can be tricky to tell. So if I'm looking at a box and whisker plot and I can't tell very well, it's easy to switch over to a histogram. And I think histograms can be easier to tell. So if we resume that, whoops, sorry, zoom 9. I think this kind of shows that you do have that tail on that positive side. Let's see, so let's go back to our box on whisker for a minute. So this data, I would say, has a positive skew. And if we hit trace, we can get the 5-number summary directly from that. 79 is the min, 87.5 is Q1, the median is 95, Q3 is 99.5, and the max was 111. Okay, so we created our box plot in our calculator. You can sketch that on your paper. And typically, if I don't have a number line, I'll go ahead and label it. And describing the shape, if this was a positive skew. Describe the center and spread using either the mean and standard deviation or the 5-number summary. Justify your choice because the data is skewed. The 5-number summary is a better representation. So that's the representation I'm going to use. The minimum was 79. Q1 was 87.5. The median's 95. Q3 was 99.5. And the max is 111. So just remember, sometimes if you can't tell on one form, if you change it to the other form, you can tell a little better. Okay, so let's make a histogram of this data. This is the last thing. And then we'll decide if we think it is symmetric or skewed. So stat edit, get back to your list, clear out the list, and put in those wait times. Nobody wants to wait in line for 89 minutes. Goodness. Love those 1-minute wait times. Okay, almost there. Okay, we have our data in, and so this time let's look at a histogram. And we need to zoom that. Okay, so here is our histogram, and you can see from that histogram that it is definitely skewed. And you can draw that in there. It's definitely positively skewed. Because it is positively skewed, a 5-number summary is a better representation. And we can get that 5-number summary again from our calculator. We'll do stat, and this time over to calculate, and calculate those 1-variable statistics. Or if you wanted, you could switch it over to a box plot and grab the 5-number summary from the box plot. So it's 1, 12, 20.5, 35, and 89 for that 5-number summary. So if you had had a symmetric set, instead of reporting the 5-number summary, you would report the mean and the standard deviation. We're going to focus a lot more on symmetric data next time. So a lot of the data sets that you'll look at today are skewed, but some of them are symmetric on your homework. So the homework assignment is 11.3. It's green in your notes packet. That will be due soon. We have one more new topic this unit. 11.4, we'll talk about normal distributions. And then on 11.5, we'll be collecting data and analyzing it. We'll review the next week and take our stats test after that. So make sure you're keeping up on your homework. That is it for today.